Greetings everyone, my name is Mewail Gidey and today I'm going to present to you automatic reinforcement. This is part of the live workshop and this is the recording part. Before we dive into the topic, I would like to start with the agenda. First, we're going to start with the introduction. We will see what is the background to this topic, in a sense, what was the reasons why it was necessary to develop this technology, and we move on to the principles, how the whole thing works. We will dive a bit deeper and see how everything works behind the scenes as well. Then we're going to see two examples. One is with the precast girders, another is with the retaining wall. Finally, we will see also how we could produce drawings, because obviously that's the one of our final goals in our design. So let's start. Normally, when we reinforce bars or when we model reinforcing bars, if we use a 2D CAD approach, it was quite easy in a sense. We just need to draw a set of lines. As you've seen this picture, we have like a set of lines. This set of lines basically could be a representative of our bars, and this was as easy as just drawing the lines. Only problem with this 2D was that it never really gave you the whole picture, so you really never like see if there is a clash, if there are bars which are quite inconvenient to do in the construction site, or other issues. And even also the communication, also this was also an issue, because when you generated the layouts and so on, sometimes you oversee certain parts of the layout. So there were certain issues, not certain, but a lot of issues, to be frank. But obviously there was an advantage, which was it was quite easy and it was quite fast. And these issues were solved or addressed with this BIM approach. With BIM approach, now we could see the whole picture. So in a sense, you could see in the picture here, we could see the whole picture of the reinforcement. So we have all the bars laid out there, modeled in 3D, and we could see everything. And if there is a clash as well, we could all see that as well. And there's other issues as well, we could see all of them. Only problem with this is it takes a bit of time and it requires a lot of work, because we have to model all the rebars in a 3D environment. So what we're proposing is, or what we are pointing out is, we need a new approach to address the rebar modeling or the reinforcement modeling. That is, we need a quick one, and which is fast or easy as well, but also which gives you the advantages of a BIM model. So it needs to lay out all the bars and the reinforcement all in 3D as well. So for that, we proposed or we developed a new technology, which is this automatic reinforcement that we're talking about. Obviously, we wanted also to address the need for change management as well. So what happens if you change the height of the girder, or what happened if you change the widths? In this case, the reinforcement should also be able to adjust to that requirement. And we did this also by introducing the parametric design approach. So all these things, that the automatic and parametric, they all come together and they create this new technology. I will dive into the workflow, but just to give you an overview how it would work, before we jump into the product. First, we have to define a set of shapes that define the reinforcement. So if it's for example transversal bars or shear bars, we need to define the shape. If it's a stirrup or a tie bars, we need to define that shape. Then we need to set the properties. We need to say, okay, we want to have bar diameter of this, amount of reinforcement, and so on and so on. Then finally, we just recalculate and bring this back from ALLPLAN Civil to ALLPLAN Engineering. There in ALLPLAN Engineering, we could adjust as we wished, and we could finally produce the drawing productions. This one more issue, or one more important thing that I would like to mention is, which is quite essential, is the transfer of reinforcement area. Normally at the moment when we transfer reinforcement area, we're just sending it from an engineer to the drafter via, via different medias. So it could be text, or it could be email, or whatever it is. problem with this is it doesn't really apply to the principles of BIM, where we're trying to make our BIM model as a single source of truth as possible. So we would also like to transfer the area all with this model, or we just want to put the reinforcement area part of the model as well. And we are able to do this with this approach. So with this technology, we could add the reinforcement area in ALLPLAN Civil, and from ALLPLAN Civil we could transfer the area itself to ALLPLAN Engineering. There in ALLPLAN Engineering we can send this area, we can recalculate, check whatever we want, and send back this area to ALLPLAN Civil. I'm going to show you all these things in the product, but overall this seems like 1 to 3 steps that you need to do to get to the automatic and parametric reinforcement. So let's go and jump into the product. Here, as you can see, I have ALLPLAN 25 and it's an empty project. You can normally start a project from here by using the project and resource management option. Here we can start a new project by adding a new project and naming that project. So we could say this workshop auto reinforcement. Let's call it X. Obviously we could set this thing up wherever we want it to be. It could be a local file, or it could be also in BIM Plus or other locations as well. At the moment we don't have any template, so I'm just gonna press next. We already have that project, so we can name this one auto reinforcement 01 instead. Then we can name this one like this, and we can set everything up. As you can see, we don't have anything here, nothing. It's quite empty project. The normal workflow would be to go here and link it up to ALLPLAN Civil and work or design your model in ALLPLAN Civil and do the calculations as well there. And from there you can bring it back again to ALLPLAN. Before we do that, I would like to set up 1 or 2 things. Here I would like to show you, we have options here. These options allows you to set up a few things. First one I would like to set up is the reinforcement. So I want to color the reinforcement based on the bark number, on the diameters. So we could do this by going to here, choosing the surface colors from diameters. From here we can assign the bar diameter. So I would like to use a couple diameters. So I will just start with 12 here. I want to color it green. I'm going to add another one, is 14 millimeters, and I will add this one is color blue, something like this, and add another one with diameter of 20 and color this one to pink. This part is like for the animation, and if we move here we have the option also to set up for the reinforcement. So we could choose what standard we want to use. The concrete grade, this is the default concrete grade that we want to use. Of course also the default reinforcement grade that we want to use as well. And here we have the option to choose the maximum bar lengths, minimum bar lengths as well, and so on and so on. We have a set of options here that we can choose. For now I'm going to leave it as it is, because I would come back to this later and we could change a few things here. Okay, let's now set it up with ALLPLAN Civil as well. Here I'm choosing the license. Okay, as you can see, we have an empty ALLPLAN Civil project as well. The same thing, we have also the options here in the project setting, where we can set up also design code if you want to, for example, other settings as well. We can set them up directly from here. If I want to have a national annex here, I could choose here, for example, the Austrian standard. Here I have also other options or other settings that I can set up here. The same also here for the project information, and for the data exchange here I could set an offset if I need to, I can set the bridge type, the IFC, and so on and so on. I can set everything here. To show you, just to give you also an overview of how ALLPLAN Civil is arranged. So here we have a set of inputs or set of tools that we need to design our bridge, for example, in this case, or to design anything for that matter. And we have also here the tools or like the functionalities which will also align with that. So I'm going to start with an axis of normally we can start with anything. So I'm just going to start with the straight axis of 20 meters. Here I would set up also simple cross section, a rectangular 1 meter by 1 meter. As you can see, it's just nothing here. Then I would move on, as you can see, I would move on and set up girder here. New girder here added, and setting it up from 0 here all the way to the end here. So as you can see, this is our structure basically. We could normally go on and import this to ALLPLAN, but I want to import it. So this is the standard or the classic way of importing from ALLPLAN Civil to ALLPLAN, but I want to import it using a custom tree. So a custom tree is like a navigation tree that allows you to navigate through the project directly here in ALLPLAN Civil, and it also allows you to import a project from ALLPLAN Civil to ALLPLAN in a specific manner. So if you could set up, okay, I want to import only if I have a set of objects here or like a set of girders, for example, in this case, and I just want to import only this one, I could specify that here. I just do that by creating a new custom tree. So we can call this one my bridge, and here I could add an item, tree item like this, then just link this one to the existing member that I have here. So I can link this thing up, so I could say, okay, I just want to import this one directly to ALLPLAN. I could specify that here by saying, okay, use for ALLPLAN, meaning I want to use this one for importing to ALLPLAN. Then in that case, I have to specify like which element goes to which drawing file. Normally by default, they are all set to 0, meaning that they will not be transferred to ALLPLAN. But if I want to, I could say, okay, I want to transfer it to a drawing file number 100 to ALLPLAN. Then I just need to recalculate here, then import it. One more thing before I go there is normally I showed you here to just link it to an item, but you could also just drag and drop this one here, just add it there as well. But because we have it, we don't need to do that. If I go to ALLPLAN here, just come back. So normally I would just do this one, update ALLPLAN, because I already did the link here. I'm just gonna here, so come and update the project directly itself here. As you can see, we have a set of options here as well, and these are specifying or asking us, okay, do we want to import an axis here? I don't want to import the axis. The extrusion paths here also the same, I don't want to import them. Tendons, let's leave it. At the moment we don't have any tendons, but later we would want to use that as well, so let's leave it as it is. Then once I import my project, we could see that we have the girder or the structure here imported to ALLPLAN. Here there is nothing really special about it. I just wanted to show you how the import works. Quite simple. So let's go back to our structure here and let's add the reinforcement. So normally we said we could just directly reinforce this in ALLPLAN with no issues, but we want to do this with the automatic approach. So how we do that is, if I go here to the cross section, here I could just add the reinforcement by specifying the property set. Here I'm just going to specify where I want to place my longitudinal bars. Just going to add a bit of offset from the edge as a cover, for example, and just place them there. Normally you would add the property set from this icon by choosing the reinforcement, for example, in this case a longitudinal ones. It's asking me to select the beam, so in a sense the structure. So this is my structure and I want to add the bars directly there. Here I have a set of options or a set of properties. The first is like the boundary. I need to select the boundary. For that, I could, if I had a boundary, I could choose from the existing boundaries, but because I don't have any boundary, I'm just gonna create my own boundary. So I'm saying, okay, I want to start from here, go all the way there, and I have the bars there. And if I just select it here, you can see we have the longitudinal bar and the boundary is selected there. So if I choose this one, you can see it's the edge, but if I choose this one, you can see it's this one. So they have a different also colors. Here I have the possibility to choose a material. We will come back to this later, but for now we could also leave it as it is. But normally the workflow would be you just have to choose from the existing material. Because I don't have any material in my project, it's just an empty one. Here we have to specify the diameter, so I'm gonna use 20 millimeters of diameter. And here we have, these are used for the calculation part and for the design checks as well. And here we have the reinforcement area. We can specify how much of a reinforcement we want to use. So let's use 25 centimeters square. Then these are, once we set everything up here, we move on to the link of the automatic reinforcement. The automatic reinforcement, the best, they work best on Python parts. So for those of you who are not familiar about Python parts is a technology that allows you, it's because it's basically exposing the whole API of ALLPLAN. So it allows you to create new functionalities, and it also allows you to create new objects. So these objects are, we call them Python parts because these are objects where you could set a set of inputs and you could really create what kind of geometry you want, including reinforcement. And these are, of course, could be considered as parametric because you could really just create them once and just double click and update them also again. So you have a set of inputs or parameters which control this object. So for us, for our automatic reinforcement, because the reinforcement, the concept reinforcement is working based on this Python part, we have to choose the right Python parts. If we use, if we click on this, on the parameters, we have new dialog. This dialog, we have a set of topics or inputs. The first is we need to choose the ALLPLAN Python part. Here we have also to choose the favorite. Then we have here the parameters. If I choose here, this one for the longitudinal reinforcement, here if I go to bridge here and reinf here, by default it's there. But if you open it also, it's just going to open this one. So these are a set of, like I said, these are a set of Python parts which are coming shipped with the product. So we have lists of them, but normally you could also extend any of them as you wish or create your own as well. So they will just be listed down here, then you will choose them. And yes, so here it's only going to show you the list of longitudinal reinforcements that you have here. But normally, like I said, we have a list of shipped Python parts which come with the product. So we have for longitudinal, we have for shear, we have for torsion, we have list, and you could just choose which one you like and you could link it up. And for the moment, because it's longitudinal reinforcement, it will only show it that, but there are more lists which we will see later when we choose a different reinforcement set. We choose the longitudinal one, this one, and we have already set everything up. Here you could see the inputs also for that, so we could also control these inputs as well directly from here. For the moment, I'm gonna leave them as they are. Then we have also this Python part favorite. So for those of you who are not familiar with these Python parts as well, so these are Python parts, like I said, a set of parametric objects where you could really change a set of the list of parameters and change the object. But normally these parameters that you would want to change, you could also save their setups. Or for example, if it was an object which has a length of, I don't know, X, you want always to specify the length of 10 meters. So you could do that by setting it up in the favorite. So this favorite, they set up settings for these objects and save them as they are as an input. So you could also, if you have a favorite, you could just come here, click and choose the favorite that you want. At the moment we don't have one, but we will create moving forward. Here, like I said, we could set up, okay, for example, if I don't want to I want to change, for example, this placement order, this variable, I can just click there and set it up here to 1. But at the moment I don't want to do that. I'm just going to leave it at 0 and save everything I want here, and then just recalculate here. Here you would see that we have this icon, and this icon is indicating we have a placement. So this placement could be this automatic reinforcement, or this placement could also be the other placements that we have in ALLPLAN Civil. Now we just done everything that we wanted to. We just recalculate and we come back to ALLPLAN here and just click update. You could now see we have the bars created here, and if I just I'm gonna just go here to the objects, make our concrete part a bit more transparent, so you can see it's quite transparent. And we have here the reinforcement, the color pink, because we set this up at the beginning of our project. We said, okay, for bars of diameter 20 we want to have a color of pink. Then you can see we have the reinforcement set up all the way from the beginning all the way to the end. Obviously we can come back here, set up or change few things, and if you want we could also go back to Civil, ALLPLAN Civil also, and change things from there. The moment I want to show you here what are the inputs and visualize them directly here as well. So the first input is the placement order. This one is for grouping purpose, so at the moment we don't have any grouping, and I will come to that what I mean by grouping, so we're gonna leave it here. Then moving on, we have the general here, and these are the settings. So we have a concrete grid. Remember guys, we did not set any concrete grid, and this concrete grid is coming by default directly from the ALLPLAN. Here, if you remember, we have a default here, so that's where it's coming from. The same also for steel grid. We have not set any steel grid there. And the bar diameter is the one which is coming from ALLPLAN. It's not editable here because this will not change here. You cannot change them here. You have to change everything for this one directly in ALLPLAN Civil. Here what you could change, for example, is the bending pin roller. You could set it up here. We can leave it at 4 for now. Then moving on, we have edit regions. This option allows you here. This option allows you to change the reinforcement area. Here it shows you the start station, which is 0, 0, and the end station, which is 20 meters here. The length overall is 20 meters, and the area where we use 25 centimeters square, that is also shown here. If I want to, I can change the area here. If I want to, I could also add more regions like this and change them here. The moment we're gonna just leave everything as it is, but normally you have the option to do that. The area, which if you remember was 25 centimeters square, which was here, and it is indicated by this green line here. So this is an area coming directly from ALLPLAN Civil. This area is the area inputted by the user, so the user input area. But we also have another area directly from ALLPLAN Civil. This area is calculated area by the product. So the product will calculate and say, okay, instead of the 25 you indicated, you must use, for example, 28 or something like that. So that area would be also transferred directly here to ALLPLAN Engineering. That area would normally be indicated by this red line, as you can see here, but because we don't have any setup for the calculation, so it did not do anything, it would be just by default 0, 0. But normally the idea is, like me as a drafter, I would have two options here, or two areas here. First area would be indicated by this green line, which is an area inputted by the user, and another area would be area indicated by red, which is an area of the product. Then I have an option to make an informed decision where I could just say, okay, because I have these two areas, I would just set it up like this and have my reinforcement drafted in such manner. Obviously you might even ask, okay, but what if the drafter uses a different area, but how could they get, or how could they send this area back to the engineer or to the one who's an ALLPLAN Civil side? So we could also do that by transferring the area back from the drafter all the way to the engineer, which is quite a groundbreaking approach to this issue. That I'm going to show you also how we will do that. If I cancel this for the moment, we will just have everything as wished. Here you can see nothing changed, but I'm going to start changing a few things here. The first one is here, as you can see, we have anchorage. So this would be a list of tables. A list of tables based on the regions, because now we have one region coming from the beginning all the way to the end, and that's all shown there. If I want, I can say, okay, I want to change the start length, which is for the anchorage. So I want to anchor it at the beginning. So I could say, okay, let's anchor it maybe 1 meter. At the end, let's anchor it maybe 2 meters. So we could say that and just close it. As you can see, we have the anchorage outside of the concrete part, like for 1 meter, and another one also here at the end for 2 meters. Again, if I want to, I can come back here and change just these ones back to 0, 0. I really don't need them at the moment. An important piece normally when working with reinforcement is the splicing. So where do we splice them and at which lengths? The moment it's 14 meters, which is the same with the default one. But if I want to, I can just change this one from 14, for example, to 12 meters. Remember, our structure is 20 meters. So if I splice it at 12 meters, I would have like two reinforcement sections or two reinforcement bars. And if I just save it here, as you can see, we have the bars which are spliced from all the way from here, and we have another bars which go all the way from there to there. If I just zoom in here, we could observe that like there is a clean cut here. If I just also go to the 3D here, what I could do is I would just hide this structure so we could see this part more in detail. So you can see we have a cut here. This is quite close, so you cannot see it so much, but I will show you how we can see that. So we can see we have a cut here all the way there, and this is our cut. What I'm gonna do to show you this more in detail is, if I just come back here, I have a possibility to say, okay, overlap lengths. So this is normal if I splice the bar here like this, and how much do I want to overlap them. So it could be meter of 1 meter, it could be length of 1 meter, so it could overlap like this. If I want to, I could set up like 1 meter here, but for now I just want to show you how the overlap works. So I'm going to put -1 meter here, and it will show you here we have an overlap. This is going all the way to the negative side just to show you that, but normally we could do that as well. So the overlap would also work like that. If I set 1 meter, it just overlap, so we might not see it properly. But the issue still is like the bars are spliced like at the same location, so they are all spliced in a clean cut. So that's what I want to avoid. How I could do that is I just come back here, set up a staggering distance. So where do I want to stagger them? So let's set up the staggering distance of 1 meter for like example. So in a sense, I want to cut them in different locations. If I come back here again, you can see the bars are staggered at different locations. So we have bars which stopped here, the other ones come here, and so on. So the location of these bars and these bars are quite different, and it is also alternating. So you can see that. Normally I did set up this because I have an overlap distance of -1. I will change that to a +1, but just wanted to show you that the overlap, the staggering distance, or the staggering of the splice. Here I come back and I just change this one, the overlap, from -1 to +1, and we will see we have an overlap here. And this is going to be a bit difficult to see, but let's select this object which goes all the way to here, and we have the object here, and which is quite not easy to visualize directly there, but here we could see that. So we have another object coming all the way. So this object comes all the way to here, when we have another one which is coming all the way to here. So we have this one coming till this part, and this one coming till this part. So we have an overlap distance of 1 meter. And the cuts, you can see them, we have the cuts for the others there and for the other ones there. So we have in 2 different locations the cut as well, because of the staggering. And if I move a bit more, I could see, okay, here we have other few settings which are also similar things. So if I cut it if I have like an overlap and I have different splices, and I can say, okay, do I want to have an overlap at the start or at the end? So I can specify that also. Start and end are like just at the beginning of the structure or the object, and at the end of the object. Which at the moment, because we have one region, this would be the same as the anchorage. So if I put 1 meter here, it would be the same as putting 1 meter here. But the difference would come here if we have more regions. More regions meaning, in a sense, like we have different areas of reinforcement along the member. That we will see also more in detail when it comes to the transversal bars, because it makes more sense to use different spacing for the stirrups or for the transversal bars along the structure. The moment there are no more settings that I would need, I'll just close it as it is. But still we would have, you can see we have the cuts here, and we have that. Maybe what we could do is, because I want to show you something, I'll just add this one, the anchorage at the beginning to 1 meter and at the end to 2 meters. So I'm gonna leave it as it is now. So we have here, as you can see, 1 meter at the beginning and at the end. For that to properly see, let's turn on our structure as well. Here we have the structure, and we have 1 meter here at the beginning, and we have another 2 meters at the end. But we said, okay, we said at the beginning we wanted to create, or we wanted to automate the creation of rebars. So we did that actually. We said, okay, we have a bar, or we have a reinforcement definition of a simple line, which is similar as modeling in a 2D environment. And from that, we could really automate the creation of bars. So you can see we have created many things. We have set up many things, and we have possibility to do that because of this automation technology. But problem, or like something that normally happens, is that like we want to change things. So maybe I want to change, for example, the width here. So here it's like 0.5 meter from here. So maybe I want to change it to 2 meters. So it would be something wide, as you can see. Maybe I would also want to change, for example, the thickness. I could also do that. So if I just recalculate now, you can see the structure has changed. But I want to also add one more change just to show you how parametric the solution is. So here I have a straight axis, the end point here specified. I would change that by just deleting the last end point and adding another one based on an arc or a curve. So I'm gonna put 20 meters here and put a radius of 80 meters here. So here you can see we have arc, or we have a curved axis. But you can see I only went back and changed the axis, and the whole structure changed. So this is like the essence of the ALLPLAN civil. So like it's parametric in a sense. You can jump back to any part of the modeling process that you had done and change whatever you want. So here we came back to the cross section, we changed the wheels, we went back to the axis plan, we changed also the axis plan. So now we have curved structure. You can see we have everything set up here. If I come back here and update it, you can see we did nothing to the reinforcement, but we have defined everything. So we had the bar diameter set up already. We had the reinforcement area also already set up. And here we also have already set up the anchorage at the beginning and at the end. So what we want to see, or what we want to achieve at the end of the day, is we wanted to have this new structure created, and we want also the settings that we set up before, like the anchorage at the beginning, which is this 1 meter, and the anchorage at the end to be there also. So that's what we wanted to achieve. Besides that, we also set up here, you can see an overlap. So we want also to keep that also when we introduce any change. So that's also kept there. So here, if I just open it up, you would see we have this 1 meter and 2 meters there, and you could also see we have the overlap lengths, the bar start lengths, the start length, everything that we set up already there. Only thing which is not properly set up is now the end. Here you could see we have not correct. Maybe I can show you here more in detail if I just turn off the end anchorage length to 0. Here, if I set up to 0, we can see at the end it's not set up properly. And we can fix this directly here by coming to the option of pause. So here this works with the curve, depending on the curve type and so on. We have a few options here. So I'm going to turn off the rotation. So in a sense that if I have a curve, if I have like the curved axis, we want to create the cross sections perpendicular to that axis as it goes along with the member. So we just check this rotation, so it is created in such manner. Here this is the 1 meter at the beginning that we set up, but here you can see the bars all the way down to the end. So everything seems to work perfectly fine. We have no issue. What we want to do now is move on to the transversal bars and also play around with that. Then we will move on to our example. Here I can just turn on ALLPLAN Civil directly from here, and we could open ALLPLAN Civil back again. Maybe one thing I would like to mention here is because we have not set up anything here with these regions. So the moment there is nothing added or different, so I'm just gonna cancel it. What I want to show you here is if I go here to ALLPLAN Civil, if I go to my structure here, I could add an area or a reinforcement area as a variable. As you can see, all these are variables of the cross section. If I come back here to my reinforcement area, you can see we have no variable set up to the area. So I can do that by adding a reinforcement area. Let's call it area 1, and just come back to the longitudinal rebars here and add area 1 here. Here it's 0, but maybe let's make it 30 because now we have a bit more wider structure. And just come back, recalculate here, and if I go to my structure, my variations, you can see we have an area here. So now it's say 30 meters. If I want to, I could also just change this one, I don't know, some other values. Even if I want to, I could also set up a new table and assign it there. Because this moment doesn't really make sense, we will not do that. Just recalculate it here and come back here to ALLPLAN and just update in ALLPLAN as well. If I come back here, you would see that we have an area, it's open in the other window. So we have an area of like 30 millimeters square. So this area also got updated. If I don't want to update this area every time the engineer is updating it, so I'm gonna set it up as 20 meters here, for example. Just save it here and close everything here. You would see now the area is 20 centimeters square. Just to verify that, just go back here, show you we have two areas. The one is 20 millimeters here, the other is 20 centimeters square here, the other one is at 30 centimeters square. What I wanted to show you is the transfer of the reinforcement bar. So if I go back to my structure, remember here, open up the variations here, and you can see the area is still 30 centimeters square. But if I open the transfer values from ALLPLAN, I'd have a dialog. This dialog, if I zoom in a bit, you can see the dialog is indicating here the reinforcement area, and here we have the stations there. So it's showing me in black, which is saying the ALLPLAN reinforcement area here, and in blue is the ALLPLAN Civil, the area that you inputted directly here. You can see it's at 30, but the drafter said, okay, maybe let's try 20. So as an engineer, I could see, okay, here maybe it makes sense in this region, so I could just select that part. You can see only this part, it makes sense from the whole structure maybe to use 20, so I could say transfer that area. So here I would have an area like this, 20 this part, and the other would increase to, for example, till 15, then it move all the way to 30. I have few the options here. I said, okay, maybe I just don't want to move this one or something like that. I could do that. If I want, I can just select the whole thing. I said, okay, maybe I want to try this whole thing and transfer the whole thing. You can see now it's all on the same line. Now it's the area is even at 20 completely throughout the structure. If it makes sense, we could save it, and you can see the value being shown or given here directly. So again here the engineer has also the possibility to change. Okay, maybe 20 was a bit maybe too low, let's make it 22 and set it up like this, and just apply to the whole 22 like this, and just recalculate here and go back to ALLPLAN and say okay, let's transfer the area back again, update it. This updating, yes. So like I said, we go back here and if I click update, it's updating here the whole thing. If I come back here again, if I go to my edit regions, you would see we have the 20 meters, the 20 centimeters square that the drafter used, and we have the 22 here. You can see it's at 22 here, which is the input from the engineer. So you have the transfer of area between the drafter side and the engineer side, also the product which is for calculation. So between these three different agents we have seamless connection and we have a seamless transfer of reinforcement area. So enough about longitudinal bars, let's jump into the transversal bars and let's see how we can play around with them as well. So if I open back my ALLPLAN civil back again, and we will first define the transversal area. So like I said before, the first step normally is we need to define the shape. So this moment for the longitudinal bars, the shape is just straight bars, so we just specify the begin and the end position. For transversal bars, we could say okay, we want to have, for example, like a steer up or something like that, so we can do that as well. Here I could do a few things. The first is I need first set, like we did before, I need to define a property set. The property set is a shear, reinforcement shear here. Click here and define the reinforcement area here. So I have here a few options. So like I said before, I could either define my own property set or boundary line, or I could even use the boundary line which was there. So I could also use this boundary line number 1. This was used for the longitudinal bars. We could also use this boundary line for shear as well, but I don't want to use that one because I want to show you how you can define any shape, but we will come back again and use that. So if I come back here and start just defining something like this, so we want to have like a shear, the shape like this, and we could set up the properties. Here we have the possibility to set a material, we have the possibility to set the diameter. So diameter, let's put it at 14. We have a spacing, let's put it at 0.2. Number of legs, let's use 1. We want to use this, meaning like how many definitions of this do we have, but we only have 1 because we are drawing the exact shape. And here we need to set up the link to the ALLPLAN Python parts. So we could choose this one, we go to the Python parts, which is the shear. If you notice here, now it's only showing us the shear. Before it showed us only the longitudinal. This is because we have a filter here. It will only show you the correct reinforcement type related to the property set. So because in the property set we have the shear, it will only show you the shear ones. If you had a longitudinal one like before, it will show you the longitudinal one. So I'm going to choose the shear one, save it, and here you have a lot of, we can see we have a lot of inputs or options to set it up. Let's leave all of them as they are, save everything here, just recalculate here. After recalculating, if I go back to ALLPLAN, I would just come back here and click update. You would see we have the shear created as well there. If I just turn on, okay, let's turn on structure object from here. Let's turn it off like this. You could see we have our longitudinal bars and the shear here all the way from the member. But same issue like before, the shears are not perpendicular to the cross section. If this was a straight, it would not be a problem. So again, I would come back and edit it. First thing to notice is we have two different shapes here for selecting the reinforcement. We have a cube one, which is for the longitudinal bars. You can see it's highlighting the longitudinal bars. I have the sphere one, which is selecting the transversal bars. So if I choose that one, I have the option here to go to the paths, choose the rotation. So you can see it has aligned it properly all the way to the end. Here again, the same thing. If I want to have few things, I can change. We have the edit regions here, which is here, as you can see, a normal one, nothing more specific. So we'll just leave it as it is. And here we have options for the hook angles and so on and so on. So I'm gonna just close this thing up as it is, just to show you there is nothing different created. Just moved or like arranged the transversal bars. If I go back again, I want to set up a few things. The first is like the hook angles at the beginning and at the end. I want to set up, okay, so I want to have an angle of 90. And I want to have also another one at the distance should be 0.3, for example, so you can see it here. We have the hook angle here, and I want to have also the same on the other side. Or we could even put it at 180. Let's put it at 1.80 and put 0.3 there. If I set that one up, you would observe that, okay, we have like a hook of 180 at the end, and we have a hook of 90 at the beginning. So we have this option. Again, if I want to, I can play around here. Here you can see it's perpendicular to the cross section like this. If I want, I could also rotate it this way. To do that, I could just come back here using this angle. It's now at 0, meaning perpendicular. I could say, okay, I want to put it at 30. And if I close it up here like this, it will not work because we have a structure which is, or like a steer up or like a transversal bar defined by 4 lines. This would only work if you have one, which is mainly for tie bars. Like if I have a tie bar, I want to rotate it, that would work. I will show you that in a moment. One more thing I want to do before jumping back to ALLPLAN is let's leave this one at 0. It's about the regions. Before we said, okay, we can add more regions. It wouldn't make sense here normally, right? We have a transversal bar, so we want to have like more areas at the end and less areas at the center of the structure. So we could do that here by adding more stations or regions. So I could do that by adding the plus here, or I could also move it here like this and say, okay, I want to have this reinforcement spacing here or area there and a bit less here. I could do that. If I want also, I could just use this one because this would snap directly into the stationing, which is linked to the ALLPLAN civil. So in ALLPLAN civil, we have a stationing. So this is a structure of number of 20 meters. We have the stationing, which are at 2.5 and so on. So we have that stationing. So these are there also. So we could snap to that station as well. Here I'm gonna just change the spacing. So now it's like a 200 millimeters. I'm gonna change it to let's put it at 450. So we have that set up. And if I save it here, and you can see we have spacing which is quite different. So we have here a bit more spacing or a bit more area than the center, and this is because we have used different spacing. And again, these are all settings that I can go back and play around. This is also offset. This would mean that we have the structure. So this is the beginning of our concrete cover, our concrete here, like the placement wise. If I want to, I could also add offset there. So we have a cover also there. I'm going to show you that if I just turn on the structured solid object here, and maybe let's bring back the concrete so you can see we have the halting. And maybe what I could do is here to show you. So here we have the concrete part on the way, and maybe just to add a bit of transparency here you can see. So if I want, I could also add this cover from beginning and end, so it would move a bit in the member wise. So I could do that if I just come back here, turn this thing off, and add the placement, add concrete cover placement. So I can do that by adding 0.3 for example, so you can see it moved 0.3 here all the way. The same, I can have the edge offsets and so on, so I could also do all these things. I have a lot of settings here. But you might ask, okay, let's leave it 0.3. So you might ask, okay, these are set of inputs, but do I have to do them every single time? So this was also a question which was asked in our workshop. So the answer is you don't need to do this every single time. What you could do is you could set it up once, as we did here, and we can save it as a favorite. This was something that I was talking before as well. So I'm going to show you how we could save this one and link it up to ALLPLAN Civil directly. So I'm going to call this one shear 1 and save it as it is and close it and go back to ALLPLAN Civil. Yeah, let's go back to ALLPLAN Civil. Here, if I go to my structure, remember here, you can see I have here the shear and choose the parameters. Here I have not set anything up yet for the favorite file. And you can all see that like the values here, for example, the hook angles and so on, they are not set here, and meaning that I have not changed them here from ALLPLAN Civil side. They are changed in ALLPLAN Engineering, but they are not changed here in ALLPLAN Civil. So if I want, I can change them directly here. So it would be, okay, always use a hook angle of 90, so it would be 90 throughout the member. If I want, I could do that, or like I said before, save all the settings as favorite, then just load them. I could do that here by going to the project where we saved our favorite file, shear 1. Yeah, please notice here, like we have hook angle of 0, length of hook, length beginning in 0, 0, all the settings by default. But if I load this one, open this thing up, you can see all these things change. So 90, 0.3, 180, and so on. So the question in our live workshop is that, so what happens if I have, by normally you would have set of hook angles and so on, you would have for 90, 180, and so on and so on, all these things. So how would I save them? So how would I, or do I have to do it every single time? So the answer is like, just save this as a favorite and just reload them every time you want to use it. Notice here, this favorite that I saved just only had a setting for the hook length at the beginning, at the end, the hook angle at the beginning and at the end, also the concrete cover placement 0.3 at the beginning. So at the beginning and at the end, the concrete cover works on both sides. I will just save this one, and if I just come back to ALLPLAN, it will just be the same thing because there is nothing different. I'll just update it, still the same thing. If I come back here, this is my shear, load it up, you can see the settings there. But the question would be also, would I be able to use this favorite, the setting for the favorite with other definitions that I have? Let's try that. So here I had a definition. Here, this was my definition for the shear, this one. If I go here, I could see we have the shear reinforcement here. I'm just gonna add another one. I'm gonna add a shear reinforcement here. Use this structure. I have not set the boundaries yet. I'm just gonna leave it. I'm just gonna set the diameter 14 millimeter. The bar spacing, let's put 0.2. If I want also the same thing, I can have a variable here. So we could also do that. I could say spacing 1, and I'm gonna use that. And if I come back here to my shear inf tool, I can use the spacing. I have to recalculate my cross section. If I come back, recalculate here my cross section, and if I come back here, I choose the shear. Here I can set up the spacing to be the same value as the spacing. And if I want, I just come here to spacing, set up a value of 0.2. Go back to my structure here and come back to my shear. You could see we have a few options where we could access the properties data for the shear. One is directly in the cross section here. I could just come back here and choose this one where I could see and change few things, or just directly also from the list of the property sets. Number of legs, 1 as usual as before, and link this one directly also the property set for the reinforcement. So we use the shear. Load this thing up. Here I'm gonna leave it with nothing. I have not set anything up yet. Only question is about the boundary. What we could do is we could delete this one, the shear one, this one, we could delete it. If I go back here, I could delete this shear reinforcement here by pressing delete here, and it would ask me, do I want to delete it? Yes, I want to delete the property set as well. So it's deleted this part. Now I only have a long none, like shown here. The question is, I want to add a transversal reinforcement or a tie bars also, which are placed here at this location. So I could do that by going here. I have a shear inf 2 and choose the boundary, and I want to choose which boundary I want. I want to choose a boundary 1. So this is the same boundary. So this is the same definition of boundary is going to be used for longitudinal bars from placing the bars from here all the way to the end here, or I could also use a transversal bars to be placed there as well. So the same boundary could be used for both transversal and shear, or any other property sets that you might have actually. So I'm gonna come back here, just recalculate my whole structure. It's recalculated. You can see we have everything set up properly here. Come back here, I could just update it there. So if I update it here, normally the longitudinal bars, the area or whatever I set up for the longitudinal bars here would still be here. The area, just remember, it is set up at 20, but the area which is set up by the engineer is at 22. So this would also be kept if I just click update. Other settings also for the overlap, for the bar lengths and so on, they would also be still kept if I just set up the update. But what I wanted to do is just delete everything and just re-import back again. So the settings that I set up would be lost. And to do that, I just come back here, just delete everything, even the link in the whole project. Once deleted, come back again, import back again as well. I'm doing this to just demonstrate that you don't need to remember all the values and set up all the values back again and again. Here, if I choose, here it's recalculating again, so just, okay, yeah. Here, if I come back and say import again, I have the option to import. So this is my project, and I could also link it to other projects actually, but for the moment we are just linking it to the same project. Here I have the same project here, and I have here the option to choose the import mechanism. So it's asking me, should I just use the default import, or if I want, I can use my custom defined tree. So we define this at the beginning of our discussion here or workshop. We define the name of the tree, which was my bridge, and we want to use that to import it. And like I said before, we could just turn everything off, just import the structure and the reinforcement as well. Again, you see we have the same problem here because the setting that we set up before, it's lost because we did not do anything to it. Like I said, it's easy fix. Just come back here, and for the longitudinal bars, it's the cube. Just come back here, just set this one to rotation, close it. For the transversal bars, also the same thing. I can come back here, set it up. Okay, I want to add the rotation here. Okay, but I want to also add the hook angles again. I can also again set them up, or even load them directly from here. I could say load favorite and load the shear. But that's not what I wanted to do. I wanted to do it directly from ALLPLAN Civil, so it's also there. It's up to you where you want to set it up. Here you can see we have the clean cut here, there, so I'm just gonna leave it there because this is the transversal ones, which is showing you the middle, but the longitudinal ones are cut clean, and there's this cut there. Let's leave that one as it is as well. Come back to ALLPLAN Civil. What I want to do now is I want to set up first the favorite directly from ALLPLAN Civil when choosing the project. So every time I choose transversal bars, I want to have the hook in, so the hook angle, the lengths and so on, all set up every single time. So I could define it. I could say, okay, transversal or like shear or tie bars of hook 90, and every time I have that one, I will just load it. If you remember, we set this thing up with the different shape for the transversal bars. So the steer up it had a different shape. It started from here, it went all the way there, so it had kind of a U shape. This one is just a straight one. So if you go here to ALLPLAN also, show you here in, just turn everything off here. Here you can see it's just a straight one. So this is what I want to fix. I can do that by just coming here to the transversal bar, selected the transversal bar, which is the shear one, and choose the favorite. So I can just set it up directly from here. Say my project, I want to have a shear like this, 90, 180, defined. Easy peasy. Recalculate everything that we wanted to. Go back to ALLPLAN here and just update it back again. So this normally I'm just doing it to show you, but you don't really need to do that every single time. Just like I said, save it once and reuse it back again. Again, you can see also the spacing and so on, it's quite different because we already set it up once and saved it. If you don't want to, you don't need to set up the spacing, you can just avoid that, or the area, avoid that, and just load only the hook lengths at the beginning and at the end. Yeah, so we have everything set up as we wanted to. The same thing like the longitudinal ones, we could also transfer back the shear and play around also the transfer of reinforcement area, which is quite great so far. But still, we still have one big issue, which is the clash. You could see that there is a clash. Why like a clash is quite important is because it does really change the length of the bars. So for this case, this one was modeled like from this end point to that end point, and this has a lot of issues. So there are clashes here in the middle, as you can see, and there are also issues or problems because the bars should normally go all the way. This, for example, the transversal bars should go all the way to the back and hug the whole longitudinal bars. Here you can also see that like this. So one way I can do this, or one way we could approach this, is by, of course, grouping all these things together. So the idea or the notion of grouping is like, okay, we want to group the reinforcement sets that normally have clashes, or that we want to place them, or they have a relationship between each other. So these longitudinal bars and the transversal bars, they have a relationship, they have a connection, so they should be properly set up. So we need to hug the, for example, from the transversal perspective, we need to hug all the way the longitudinal bars. So if I come back here, like I said, I have the list here, the list of property sets. I could set them up here. So I say, okay, I want to group this, I want to group it to group 1, and group this one also to group 1. Then I just recalculate the whole thing, so they will be grouped into one. If I come back here to ALLPLAN and just update the whole thing, now you can see we have two structures, or two property sets, or two item part placements. You can see that because of the selections, as you can see there. And what I'm expecting to see is that this to come to one structure or one placement and to be grouped into one. So you can see we have the group placed 1, which is a different symbol, which is indicating that these are grouped. And if I highlight it, it like kind of selects or highlights the whole reinforcement, the whole transversal ones and longitudinal ones. But still, the issue is still there. We have not fixed it. And how we could fix this one is we could say, okay, we want to specify the placement. And you could see also the settings, all the property sets are all in one. So we have here the settings for the longitudinal bars. We could verify that because of the area here we used the 22. And here we have also the transversal bars. You can see also everything there. We can verify that by just checking the placement of the area. Again, the shape, the geometry, it's all there that we set up before. Come back here and I would say, okay, what do we want to do? We want the transversal bars to go back and hug the longitudinal bars. And what we could do is we could play around with the placement. So far we changed all these things, all the settings. So how we could avoid this clash, or how we could make the transversal bars go all the way back and hug the longitudinal ones, is by setting the placement order. Here you can see we have, this is for the longitudinal ones, and we have the same thing also for the transversal ones, and we could choose which one to place. So this is a placement order. So if you want to place an object or like the property set first, you say placement 0, then you go 1, 2, 3, 4, and so on and so on. You can continue all the way. If I put it 0, meaning to be like the beginning. If I want to put it next, so I could put 1. Here it doesn't matter, it's like 0, 1, doesn't matter. You could also say 10, then, but if you want to place this one next to that, you just say 11. So it's just like number you need to put. And if I put a value of -1, it means, so I could have a lot of a list of property sets. So if I put a value of -1 here, like this one, it means place at the last. So I wanted this property set to be placed at the end, the very last. Now it doesn't matter if I put 1, -1, or 10, because this is going to be next placed after the longitudinal ones. And if I press close after my placement, you can see we have placed it here, the corner like shown. And these are all moved all the way to the center. Here you can also see it's moved all the way to the center. Maybe one more thing here is, okay, there is a like a spacing or like some kind of space here. Probably like the reason why it is like that is because it's placing it at the center of the curve, not the beginning of the corner. So like not at the beginning here, but at the center of the bend. We could easily fix that by going here in the option here which says place at the corner, and check that and press close. And we have here, like you can see, it's at the beginning of this one. Here, not possible to see it much anyways, but here we can see it's aligned properly, same all the way till the end. Here also it's aligned accordingly, and it's not going all the way to the center here, but all the way bottom, and it's placed to aligned accordingly. You can see it here. Yeah. Same thing, I could just come back here again, say, okay, yeah, but maybe I don't want to use the 180 at the end. I want to change it from 180, let's change it to -90 like this, and change it up like that. Same thing, you can see we have the placement here, the corner at the beginning, and here also the like at the end here, which is perfectly fine. But if I go closely and see here at the center, you can see we have an issue here. Problem is because these transversal bars, they just aim at hugging the whole structure all the way there. So they are not really concerned with the middle parts, because they are just focused on hugging it. If I want to fix this one, in this case, what I could do is go back here, said, okay, instead of placing the transversal bars at the end, okay, let's just place them first, then let's go back and place the longitudinal ones at the end. So just change that to 1 and press close. You can see we have fixed the issue at the center. We have no clashes here at the center. Here we have no clashes whatsoever, and they are fixed. But still there is the issue that, okay, but this is not defined properly. Well, in that case we have to choose which one to place first. So in this case, if I want to have this structure, I would just define, or I would just create a transversal one a bit more wider, so they cover the whole structure, not just only till this part. But again, this works like 2 ways, so you could choose which one you want to place. Same, we have different other options and other settings as well. This setting, we could just directly set it up also in ALLPLAN Civil directly there. So instead of setting, okay, I want to place this 1, 2, 3 here and play around there, let's just change these things back to, let's put a 0 here and put this one to 0 also. So it's 0, 0 in both cases. So we will still have like the clash. Maybe I could change this one just to 90. So we have here, let's change this one to 90, so we have the same views. And you can see we have still the issue because we have not set any placement order. What I wanted to show you here is we could go directly to the cross section in ALLPLAN Civil and choose the property set that we want to place next, or we want to place after. So we just choose this one box here, set this thing 1 to value of 1, and directly save it and recalculate. Just come back here and just say, okay, just want to show you here again. Here we can just set everything up, and just by coming update, we can update the whole thing. Again, we have the concrete part, and I can hide it by going back there, so you can see setting up everything back. We might have observed that like it was 180, but now it was 90, but it moved to 180. This is again because we already set it up in ALLPLAN Civil, a favorite file. So for the shear, we have set up a favorite file here, the shear, and the favorite file here is going to always set up this 180. If I don't want to, I can just come back here, easy peasy, set up at 90, like that. One more thing maybe is about the variables here. And so here these variables are their inputs, and I could set them up also with variables which I have from the definitions of the variables here. So for example, what I want to do is I could have an input for example for the cover, the concrete cover here. So I can just create a new variable, call it cover 1. This point really doesn't really make sense because there is no use. We could just directly check it, but I can just change the cover here from 0.3 like this, and to be linked directly with the variables if I want. We have a lot of options here to set up all different settings, different ways. So basically this is it from the principles perspective. If I go back to my PPT one more time and just explain a bit more before I jump to that. So we said we define the shape and then we set the properties. We just recalculate the ALLPLAN civil and ALLPLAN, imported it to ALLPLAN, then we just adjust the things that we want to in ALLPLAN directly. If we don't want to do that, we can also just set up, like I said, a favorite file and include it directly there. And transfer area, this is also an optional. So if you want to transfer the area back and forth, because this would make the workflow a lot more smoother and a lot more proactive. But if you don't want to do, you could also skip step 4 and 5. But basically with step 1, defining a simple shape, setting the property, we could create automatically a reinforcement. Again, this reinforcement is a parametric reinforcement. So this is like the workflow or the principles of how it works. And if I go back to my agenda to show you here, we started with the introduction part and we moved on into the principle, how things work. So I'm going to show you 2 examples. One is a precast girder and this retaining wall. And especially the precast girder, and this is also part of the continued workshop, you will see the benefit there to really be pronounced there, like why it is really a useful feature, this automatic reinforcement that we have. Again, this is a part of a live workshop that we had, and this is the recording part. We had a workshop about precast girders, so how we can design them, how we could model them, and how we could really simulate the whole calculation as well. So this workshop was done by my colleague Ayhan, and this is also available in terms of the recording, so this would also be there. You will probably find it somewhere, the link. If I go to the example of precast girders, I will just come back to my project here. Here at the moment I just have a simple structure. I'm just gonna load a TCL file. Normally we have an option to load a TCL file directly from here, or I could just load by dragging and dropping a TCL file. For those of you who are not familiar with ALLPLAN, TCL file is just basically like a complete image of our, I'm just gonna drag and drop it, our model, so that the model, the structure that we modeled here, we could, for example, this is the example for the precast girder. If I model this one, I could just export it as a TCL file and just come back here. I could edit the TCL file. So here, if I open it, you would see I have, it's just a TCL file, and I could just, it's a text file basically. I can just go back there and edit a lot of things there. So this gives you also like a mod or like an added advantage to go through your data and navigate, go through your data and optimize whatever you wanted to optimize, or you could basically see what is there. Coming back to the precast example, we have here, it's a simple structure. We have here an axis, a set of axes. We have a main axis, we have a transversal axis at the support, the pier. Then we have a cross section. We have for the girder this simple cross section here. We have for the pier column here as well. And if I want, I could just define a reinforcement property set for that one, but before that I will just show you the whole structure. Here I have a pier, and I have the pier structure, the piles, and I have the girders there. Normally these girders, they are based on a template, so we have this template. You can see the sign T, which indicates that this is based on the template. So this is our template that we're using, and the shape and the definition is defined there. And we will just come back here and normally define from where to where we want to place it. The moment it's just a straight one, because yeah, well, it's just a straight one. But if I want to, I could change the lengths and so on, so it would be all parametric. Let's define our property set, our custom tree, and then let's import our structure. Like I said before, for this one I'm just going to work first with one girder, import this into here. So we have one girder there, used for ALLPLAN, checked, and specify where I want to place it. Let's specify 100 and just recalculate the whole thing. Let's turn off these things. We don't need the design and the checks as well, or the analysis for that matter. We just need the model. So we just recalculate it and come back to ALLPLAN. Here we will import it. Again, I'm just gonna delete everything that I had imported because I want to import the girder. Same thing, the girder, just delete everything and then press import. Then we will be able to import the girder. It's asking us which one do we want to import. Okay, so it's we want to use the custom tree. Like I said before, we have two ways of importing a project from ALLPLAN to ALLPLAN Civil. We can use directly the classic, the standard import, or we could use the custom tree. So I'm going to use the custom tree. So let's check. We don't need this axis, but we want to import the tendons. So we specify that, and we can import the tendons as well. Here we have structure, basically girder, nothing added or nothing special. But we don't have a reinforcement, so what I want to do is I want to add the reinforcement. I could add that like before we did, just by defining the set of property sets that we want to use. So just going to define one transversal one and one longitudinal one, then we could just import it. Here what I really want to emphasize is that the girder, the link girder, or this girder, it's based on link girder. So link girder in a sense is like a template. We create a template, like I said before, and from that template we create a bunch of girders. Here if I just come back to my cross section, this is my girder, and actually for those of you who don't have access to this project, you could actually access it directly from here. This is the example, the precast girder AN. Here you can just load that. It has 2 spans and it has all the definitions, so you can load that and work with that as well. Here let's define 2 property sets. Let's create one longitudinal one at the top. Let's create a longitudinal bar here. We need to define here boundaries, so I'm gonna add like 0.05 somewhere there, and that's it. Then add the longitudinal bar from there to here, defined, and just add these longitudinal bars. Let's add the boundary tree. Let's define the bar diameter, so we're gonna define bar diameter. Let's use 20 as well, and I'm gonna use also 25, or we could use actually 20 here as well. We need to specify which one we want to use. Let's use the longitudinal bar setup here, and we could also group them. We don't need that actually at the moment, but we could do that as well. And the same goes also for the transversal bars, so we could also add another transversal bars. Let's even group them actually, so it would make sense. So I'm gonna say group 1 like there, and add a transversal one or a shear one, and I'm gonna define it also there. Here I'm gonna use an offset from here. Let's add an offset 0.03, and the same also here 0.03. That one have bar which goes all the way from there and comes all the way to here, somewhere around 0.3 as well. So I could define the shape of this one by just saying, okay, I want to have it from end of the member like this one all the way down to here. The same also the other one all the way down to top here like that. So we have shear there also. If I got the shear, I have bar diameter. I'm gonna use, let's use 12 millimeters, and let's use 0.2, and let's use number of legs 1, and I'm gonna use bar meter, the placement properties, the shear. I'm gonna select that. I have here the options to choose. So like I said, we can do this directly also here. So I'm gonna say this, I wanna have it in like this. So I'm gonna add like a 90 here. Let's put 0.2, and here also the same. Let's put this one minus 90 and 0.2. So I'm gonna add that. And because I'm gonna have a group, we can avoid that, but because we don't really have a clash here, but let's just group here, so we will not have any issues with that. So just same thing, easy peasy. We just recalculate it. We can come back here directly in ALLPLAN and just click update. You would see we have the placement there, and we have everything defined. So if I show you the wireframe, they are all set up like this. We added here. We need to fix that. So let's fix that. Let's go back here to our cross section. We add here the cross section. Here I added -90. So I'm gonna make this one 90 here and do that. But you can see if normally you would want also to extend this all the way to the top or to some length, right? So you could do that. So you could just add some distance here, let's say 0.1, and we could just extend this point. So this point is like for boundary point 1 here, you can see this point, and I could just say, okay, I want to move this one by saying, okay, change the reference point. So I moved it to this one, and for this one also for boundary point 4, I could also just move it all the way. So you can see we have some kind of anchorage all the way to the top for the transversal bars. And we come here, just update the whole thing. You would see it will update the whole structure. Because everything we have set, it's there. What I want to do is, maybe there was also a question actually about, okay, are these like bars which are also of bars of ALLPLAN? So can we use all the functionalities of reinforcement in ALLPLAN? This also completely moves to the drawing production part of our discussion. So, but before we jump, I'm just going to give you an overview of what we could do. So we could just generate like a section view here, come back here and just generate like a section view all the way to here, and we have a section view here. So this is a section view which is showing all the definitions. So if I wanted to, I could add also like transversal bars here, the bottom as well, but here because we have a tendons. What I could do is I could start labeling it. So I have here the options to do labeling. If I go to the labeling, I have a lot of things here. I could also use the, for example, the full schema or like the partial schema. So we could generate, for example, the partial schema of these transversal bars. So we could put them directly there. So you could see we have our reinforcement there. So everything, the labeling, the section view, everything that you could do in ALLPLAN, you can do it directly here also. What we wanted, or like what I wanted to discuss here, is that so we created this at the cross-section level. So this cross-section is being used in all the structural, all the girders, because the girders are all based on a template. So this template is using, like if I go here, if I go to the cross-section here, you can see it is all using the girder cross-section, and you would expect it to work in all the members. So I only reinforced at the cross-section level, but I want the reinforcement definition to apply to all the members. Well, it is actually applying to all the members. I'm just not importing the whole thing. So I could just import the other 3 as well, just import them directly here. So you can see I have all the others. If I click here, you can see it's only importing, like I said before, the number which has the drawing file number which has some value besides 0. I could just add, because they are all 0, so I could just add the enumerating, and I add from 100 all the way to 101, 2, 3. So they all have a drawing file. So again, just recalculate everything and come back here. Because they are going to be placed here, I'm just going to move this whole thing all the way down to here somewhere, and then just come back here and update my structure. And so the goal with this, what we want to see is we've only reinforced one structure, only the template one, but we want to see it in all the other structures as well, because they are all based on this template we have created for this link girder. And we would see that, okay, we imported all of them, and we want the reinforcement also to place for all of them as well. And you have here, you can see, you have the reinforcement for all of them, for all the structure. These are just like one small span and only has like 4 members, but imagine if you have like multiple spans and a lot of girders. So this would really be beneficial because you don't need to reinforce all of them. So normally you do that. Or you might even argue that, okay, it's a precast one, so they all have the same like definitions and so on, so that's why it's working. Well, technically it is more than that. So if I have if I just open back again ALLPLAN Civil, so what I want to show you is like, okay, we might have a different lengths or even change the whole lengths. What we expect is to work the reinforcement definition in all of them, because we're defining it from like the cross-section level, the cross-section that we want to use. And we could do that if I go back to my structure here directly in ALLPLAN Civil. Here we have a definition for the girders, and if you see the girders here, they are placed like we have a placement from this position to the other position. So we're using a transversal axis placements here. And if I, for example, if I go here to my axis, this is a transversal axis 1, and this is my transversal axis 2, this one. And if I want to, I could add a plane angle. So I'm gonna add a plane angle of 30 degrees, and we would want to have like a placement you could see like that. So we have this placement. They have, good, I expect they have different lengths, and I want this to work also in that manner for the reinforcement. So I will just come back here, did nothing, just change the placement of the transversal axis. So I wanted to rotate, and it did rotate, and you would see the rotation applied and the reinforcement also created. So you can see they have different lengths, but still we have the definition of our reinforcement as well. The same goes also here, the definition of the sections that we created here, it's also there. We could of course label it, and we will have all the information there as well. The same goes if I have a table also definition. If I go here, I create a table definition. I create a table for definition of reinforcement area and so on, that I could just apply it directly here to my template here. The variations, and this would be, because I don't have any variations, this would also be then applied to this member, and not only this member but to the other members who are derived from this template. So we have all this workflow. And again, if I have a tendon definition, here, like you see, these tendons are also imported directly to ALLPLAN. They will be imported directly to ALLPLAN. If I visualize everything here, I would go to my objects and turn everything on and turn this one to animation. We would see we have also tendons as curves and so on, because tendons here are they have diameter which is quite small, and that's why they are not shown properly. But if I have bigger area or a bigger diameter, and they will be shown there properly. And I could, tendons are normally created directly in the girder. Here we could create them using grid lines here, as you can see, and we would basically have all the definitions that we want for the cross section here, and we can say, okay, I want to have the transversal bars there, so you could really avoid also the tendons, and you could really do or create the reinforcement definitions as close as to what it would be in the construction site. So this seems the end of this example. We would move on to the second example, which is the reinforcement for the retaining wall. The idea here with this example was just to show you and point out that, like, you start the definition at the cross-section level, and the definition which is at the cross-section level could be used to create a template. In this case, we created a template for girder. The template for girder, which is then used like multiple times. In this case, we used it 4 times in the derived elements. There we could have different lengths, different, I don't know, orientation settings and so on, but still the definition that we defined the cross-section being used at the template would still apply all the way to the member, and we could have different lengths of bars and so on, but it would work absolutely fine. Again, if I want to, I can change a few things, have a parameter or have a table, even have a formula which works throughout the member. So based on the lengths, based from this, how far it is, maybe apply something, how far it is, maybe apply something, maybe apply the spacing to be different. So from the end, like from both ends, like 2 meters in, have a different spacing. For example, for transversal bars, you could set that up as well. So different things that you could do. Moving on to our second example, which is the retaining wall. sorry, imported the wrong TCL file. We could have the retaining wall here defined, as you can see, and for this one I'm using also an axis, normal axis. Normal, this axis could come through Beam Plus as a land XML, or you could also import it through other formats as well. So this axis I have, from that I'm creating a polygonal axis. In a sense, this polygonal axis would allow me to specify or like to polygonize basically the main axis that I imported. And based on that, I have here a retaining wall. This retaining wall in the cross section, if you jump to the cross section, you can see it has like quite simple definition, and it has also the reinforcement definitions there. So all these things, if I click on the reinforcement here, you can see we have a bar diameter of 14, grouped spacing, the number of legs and everything there. And this was used to create the structure here. If I click on the structure here, you can see it, go to the cross section, you can see we have the retaining wall there. If I come back to my custom tree, we have the girder specified at girder number 1, which is specified at drawing file number 10. So we want to import this one to ALLPLAN. Again, just delete the whole thing. I'm deleting all these things because I want to have a fresh start, so all the settings that I set up, I want to be removed. And I can just import this thing back to ALLPLAN by using the custom tree. As you can see, we have one group where we could open it up like before we did, and we can edit everything, and you can see it's highlighted all well and all good. We could just maybe turn this one off or make it a bit more transparent, or we could just completely turn it off, and we can see we have all the reinforcement definitions there going all the way there. We have like the hooks at the end and so on and so on. We are avoiding the clashes at some places, and others we have not set that up. But simply we could just set up all the things that we want directly here. So this is to point out that like this definition or this reinforcement, automatic reinforcement, doesn't necessarily work with set of like definitions that you would expect only to work with precast girders. It doesn't. With any structure that you define in ALLPLAN Civil, or you can model in ALLPLAN Civil, you can reinforce it. Only thing I would like to point out here is we have here different different structural member types. So we have girders, which we extrude through the member. We have piers, which are vertical objects. We have link girders, which we place between two different points or two different axes or two different placement positions. And we have decks. So these are decks which you would expect in a bridge structure, or like to be a road surface or like the top of the deck. And we have bodies, and these bodies are way more they are way more advanced objects, because you could really optimize, you could really parameterize them in different ways, and different ways, and you could obviously also add Boolean operations, so you could add them, subtract them, and so on and so on. So they are way more advanced. The moment this automatic reinforcement will not work for members which are created of bodies, but for the others, if you have girders, piers, link girders, decks, and so on, it would work absolutely fine. And if you can model it, it could be retaining wall, it could be other structure or tunnel, whatever it is. If you can model it directly here, you could really reinforce it. Obviously, this works perfectly fine and absolutely good if you have a template kind of templatized kind of objects. So, for example, for precast girders, because I can have a template of the girder, to really work well. It shows you like how like it becomes much more advantageous, because you have to reinforce the whole girders, which are like, they could have different lengths, they could have different properties, but you could reinforce them similarly by using variations table, by defining everything at the cross-section level. So we could do that. So we move on to our final part, which is the production of drawings. So how could we do that? So like I said before, all the definitions which are here are reinforcement definitions. So like the ALLPLAN definitions, so all the functionalities. If I click this one, for example, and go to the properties, you could see it's showing me the reinforcement bar mark, all the properties you expect in ALLPLAN to be there for reinforcement, they are there. So because it's a reinforcement of ALLPLAN, so it's not a new object that we created. So you could do whatever you are doing with the ALLPLAN reinforcement. Again, this is to point out that we're reusing what we had and we're using the technology for this purpose. If I go back to the cross-section definition, here you can see we have a definition. So this is a property set definition. And this property set definition, they are normally used for the calculation part. But we're also using the modeling of the reinforcement. So you don't have to define two things, like for modeling a reinforcement and for calculating two different reinforcement areas. All the definitions that you have here, including material, bar diameter, everything here, it's used for the calculation, for the analysis, and it's also used for the modeling of the bars. Yes, and coming back here in ALLPLAN, now we can generate the section views, and we can also generate the bar schedule. Then we will have our final drawing or layouts. What we could do is, like, we could set up everything in the building structure. First, we need to set which drawing belongs to where. Normally we have our custom tree, which is the navigation tree that we imported from ALLPLAN Civil. It's here. Then we add also here other like views. So I want to add like a view here. I'm gonna send a drawing file here. I'm gonna send to N3 there, and I will activate this one because I want to generate the section view. Here activated in this new drawing file, I just generate the section view. I have a lot of options how to generate that. I will just go here, for example, and generate this part. Have it as a section, for example, section 1, where we could, for example, add the bar labels. We could do that by just choosing the bar label. We have a few options we can turn on and off. I'm just gonna leave them, most of them there. And the same also goes for the longitudinal bars. We could also generate the same thing, the bars, and generate them there as well. Again, I could also generate like a schema here, the partial schema, and I can generate for this one, for example, I can generate a partial schema and just put it right next to it. This is one section view. If I want, I can add one more and just activate the third one, the third drawing file. Then also generate a section view, maybe along the along the member. So we could do that by just creating section view. Let's cut it here, and we just generated this part of the member. Again, if you want, you could also add other views as well. We have other views that you can do. You can have also options. You could also have options here to use the settings for the clipping and so on. So you could also change these things by double clicking, and they have a lot of options here where you want to change the clipping paths, which was for this case this one. And if you want to include or remove certain objects, you can also do that. And also the same with the surface element and so on. Once we do this, we could also generate the report or like the legend. So I'm just gonna add here, these are our views which we added. Then add a report here, and just gonna add the report that I found. And if I want, I could also just add like a section view or like a legend, which I'm gonna use the drawing file. So I'm gonna use 4 here and just add my legend, my bar schedule, and we could just generate the bar legend here. And the bar legend, we have also a lot of options where we could add bending shapes with or without, and also other properties. Just gonna add the shape. So we have all the shape, and you can see you have the shape and the lengths and so on, all the bar pieces, numbers, and so on. At the end of the day, we also have the total mass. You might observe that like there are like 0, 0 for the kilo masses because we have not assigned the steel grade, and this was also the same warning that we saw before. Then if we go to our layout editor, here we have the option to set up our page. So you could set up the page using this, and you can change the page, I don't know, to A3 for example, like this, A1, A0, and so on. So you have a lot of options. So let's just use A1 for this case, in this example. Here also for the legends or layouts, you could also change here what you want to use. This is for the page. If I went, I could also change the legend. I could say I don't want to use the legend, or use a label, or other options as well. So I have a label here I could use, but in this case I want to use the ALLPLAN one. Save that one and close everything here. Then next I'm just going to add the elements. So here we have the option to choose using the drawing file which one we want to use. So let's start with the girder. So the girder meaning the structure that we created. So let's put it somewhere here. This is our structure. Then we can choose whichever we want. Then I would go for the second one where we created our section views here, as you can see. And here we have also other views, and here we have our bar legends. And this is basically the structure. It continues all the way throughout like that. If I don't want to, I can move it like that. And if I want this one to be arranged properly, I could just move it back here so it is properly set up. And the same as for this one, I could just come here and set it up properly. Like that. So we have everything that we wanted, and we defined everything, and we also have like the bar bending and schedule there. The same, it also goes the same with our concept. So if I go back and change, for example, structure here, I could change let's change, for example, the height, the length of the element. So we could do that by going to okay, it's already open. We have our structure here, and the length of this was defined here and based on the station. So the stationing, because it was defined here, we have a 10-meter structure. If you want to, we could just add more station there. So by just adding a station here, I will make it 12.5, and we would observe that it has increased. So the structure has increased to 12.5. Then obviously I'm just showing you like how to change the legs. You can change whatever you want. If I want to, I can come back here to my retaining wall and say, okay, maybe this is, I don't know, this is way too high, the height, so I could change it also. This is like 3 meters, so if I want to, this is also parametric, you could see, I could change it to 2.5 also, would not be a problem. Then we'll just recalculate everything. You can see it's way shorter now. We can come back here, just update what we have created. So what we're expecting to see now is we want to change the reinforcement. It should be changed automatically. We're also expecting for the views to be maintained at least, and some of the labels we need to redo again. And obviously the bar schedule, that needs to be also updated automatically. And Yeah, so as you can see, we have our reinforcement. We could just turn off the concrete part. So we have our reinforcement model there, and we have everything. We have our view, section view that we created for both of them, and we have our bending schedule also updated accordingly. So before it was 10 meters, now it's 12.5. The same goes for our layout. If we just update our layout automatically, we could see everything has also updated. So it's 12.5 and everything is updated. Only thing here, our labels that we have assigned them, because they are not associated, they are lost. So we have to redo them back again. So this brings me to the conclusion part of my PowerPoint, where I would like to point out that for the idea or the goal here is like we would want to improve the modeling of reinforcement, and this applies for any structure regardless of what it is. So from simplified definition, you could really create the whole beam model of our reinforcement, and this is also parametric. Thank you everyone.